sine, which is opposite over adjacent. So this is opposite over hypotenuse. I'm sorry, that's your SOA. Cosine is your ka, which is adjacent over hypotenuse. TOA is your tan, which is tangent equals opposite over adjacent. So instead of having to write these long descriptions out, we just came out with SOHCAHTOA. Some old hippie caught another hippie tripping on acid. Okay? When I was in high school, I went to high school with this African kid, and he did not like hippies. He said, "Who talks about hippies? Where are hippies? Who are hippies?" And he just went off about it. And so he said, "How about this?" So he said, some old homeboy caught another homeboy tripping on, and then he would just yell, "Hey!" at the end every time. And he said,
"Oh my God."
Yes.
So, homeboy caught another homeboy tripping on a hey!
And that's what he would just yell every single time. And we had a quiz, and we look over, and he really yelled out that at the end. A can be whatever you want at the end. But this is a school environment, so we're going to keep yelling A and just let it be A. Okay? All right. So you can remember it as the Indian of the math problems, SOHCAHTOA. You can remember it as some old hippie caught another hippie tripping on acid. Or you can remember it as some old homeboy caught another homeboy tripping on A and call it a day.
Quay got a good one. No.
Okay? However it helps you, go with it. I just want you to remember it. All right. So what this means is that this tells you what angle is your perspective coming from. So if my perspective is coming from angle A, when it says opposite, what is opposite of angle A? What side? A is opposite of it, right? So that's going to be my numerator of my fraction, lowercase a. When it says length of the hypotenuse is always just the hypotenuse. The hypotenuse can never be adjacent or opposite of an angle, okay? So my hypotenuse is C. All right? Now it says adjacent. Adjacent means next to. So looking at angle A, what side is adjacent to it? B. This is next to me. And my hypotenuse is again? C. Okay? So now it says the length of your opposite. So what was my opposite?
A.
Over the length of my adjacent. And what was my adjacent?
B.
And that is how you utilize sine, cosine, and tangent. So far, sounds simple enough, right? All right, now let's throw in some numbers. So what is my angle of perspective? D. So looking at angle D, sine means what? Opposite over hypotenuse. So what is the opposite of D? 5. What is the hypotenuse of D?
13.
So guess what sine is? 5 over 13. That's it. I'm positive. That's it for right now. No tricks. Okay? Cosine.
A over H.
A over H. So adjacent over hypotenuse. What's adjacent to D?
12.
And what is the hypotenuse of my triangle?
13.
That's it.
What's the catch?
There isn't one. All right, tan.
It's going to be O over 8.
O over 8. So opposite over adjacent. What is opposite of D?
5.
And what's adjacent to D?
12.
Guess what? You just found your first sine, cosine, and tangent in this class. Hopefully you did it last year or 2 years ago.
Didn't do it at all, miss.
Okay? So let's look at now what's our angle of perspective? Q. So Q is our angle of perspective. So is my opposite and my adjacent going to change? Yes.
H over O.
No, it's going to stay O over H, but my perspective is going to change because now I'm coming from here. So what is opposite of Q?
12.
12. Oh, pooey. My thing stopped working.
What one with 13?
Sorry, I broke it.
I'm snitching.
Well, I didn't break it. My butt unplugged it. All right, what was it?
13? 12. 13?
12 over 13. Okay. What is, looking at Q, what is adjacent? And
A over H. 5. So it's going to be 5 over 12.
5 over 13, because my hypotenuse is
13.
I'm listening to this dude.
That's why you knew this.
don't listen to anyone else but yourself.
No, I'm just kidding.
Because you know you try to talk at the same time as
I just want to
somebody.
make him feel bad.
All right. And then what's 10?
12 over 5.
12 over 5.
Beautiful. You are smart. All right, there is a relationship. Look at my sine and my cosine.
They switch numerators and
Okay?
denominators.
So the sine of D is the what of Q?
Opposite.
The sine of D is what of Q? It's the cosine. The cosine of D is the what of Q?
The sign.
The sine of Q.
Sine of Q.
And what is the relationship between the tangent?
They just flip.
And what's their what? I heard the word? Reciprocals.
Ow, ow.
I don't know what's going on. Reciprocals. Reciprocals means that we just do what with the fraction? Flip it. The numerator and the denominator switch places.
So it's always going to be the
It's always that way. So if I know information about one angle, then I know information about the other angle. Essentially, you do not have to solve it. Okay?
So it's always
All right. The next one we're doing is because I want to emphasize on the fact that you need to reduce.
So what? Well, another page.
No? All right. So what is sine again?
O over H.
O over H. Opposite over hypotenuse. And my hypotenuse is always the same. Okay? So what's my angle that my perspective is coming from?
12. T.
T. So what is the opposite from T?
15. 12.
12.
I got confused, but I know it was a 12 though.
And my hypotenuse is
15.
cosine of T.
It's going to be
9.
A over H.
Adjacent over hypotenuse. Tan of T. 12 over 9 because it's opposite over. Are these simplified fractions?
No.
They can be simplified, right? What is 12 over 15 reduced to?
3 over 5.
3 over
4.
4.
4.
What is 9 over 15 reduced to?
3 over 5.
3 over 5.
And what is 12 over 9 reduced to?
4 over 1.
4 over 1.
2. Wait, no.
3.
4 over 3.
Okay? So if I know all of this about T, can I use it to solve for everything about P? Do I really need the picture anymore?
No.
No. Because the sine of T becomes the what of P? The sine of T,
The cosine.
the cosine. So what's the cosine of P?
4 over 5.
Oh, yeah, 4 over 5. And the sign is very different.
The cosine of T becomes the sine of
P.
P, which is,
3 over 5.
and what happens to the tangent?
It's the reciprocal.
It is the reciprocal.
3 over 4.
So it becomes 3 over.
4. Okay, now vote for real. What's the catch?
There isn't one.
This is too easy.
There isn't a catch.
I'm just saying, because it's always really easy when we're doing the notes, and then the homework comes, and it's like crazy.
There's no catch, I promise. All right. Okay. Just what is the difference between this problem and this problem?
It's a 30. Oh.
What happened?
This word.
They gave us an angle, right? That doesn't matter. They gave us an angle, and what that angle is telling us is that that's where we start at. So what angle are we looking at?
30.
30. So we're going to go to 30, and we're still going to do the same rules.
So the opposite's going to be
It'd be 5.
So the opposite is,
Which would be 1.
and my hypotenuse is,
1 half. Oh.
which reduces to,
1 half.
Hold on.
Hold on, wait, no. Okay, the opposite of 30 is 5.
It's 5. Oh, square root. And the opposite of 5 is 10. Question, how would you know that's the hypotenuse?
your hypotenuse is always the side across from the 90.
Okay, I just my head's starting to hurt.
Okay? Alright, cosine means what?
It's the opposite. It's the opposite of it.
Adjacent over hypotenuse.
Adjacent over hypotenuse. So from 30, what is this adjacent?
10. 5. Is it 10?
5 square root of 3.
5 square root of 3 over 10.
How would you make it 3 now?
Okay? Do I have another radical for my radical to be combined with? No. So I leave the square root of 3 alone. Can I simplify my numbers now?
Yes.
What's 5 divided by 10? 1.
1 over square root of 3.
You don't put the 1?
Is there any point of putting a 1? No, because anything times 1 is its self. Alright. Tan of 30 is?
Over H is going to be 5 over square root of 3.
5 over 5 square root of 3. So 5 over 5 square root of 3. What happens?
It'd be square root of 3.
It's just a bit.
Keep the square root the same. You put a 3.
What happens?
Cancel out.
Are we allowed to have that?
Yeah.
No.
Are we allowed to have a square root in the denominator?
No.
No. What do I do to get rid of it?
Rationalize.
I ratify.
Square root of 3 over 1.
Times square root of 3.
When I ratify, I'm left with the square root of 3 over 3.
Yeah, I knew there was a key.
What was the catch?
But hold on. Wait a minute. How did you make it a denominator and numerator? From 1 over square root of 3?
I ratify.
I mean, like,
Ratify means I take what the radical is and I times it to the numerator and I times it to the denominator. 1 times the square root of 3 is?
square root of 3.
Square root of 3 times square root of 3 is?
Right.
Square root of 3 times square root of 3 is what? Square root of 9. And what's the square root of 9?
3.
3.
So what are we going to do whenever we have to do the tangent on it? Yeah, because you have to flip it.
Well,
Are we going to just re-ratify it?
or use the original and find the reciprocal.
Oh, yeah.
All right, so sine of 30 is the what of 60? Sine of 30 is the what of 60?
The cosine
It's going to be 12.
be 1 half.
So the cosine of 60 is?
1 half.
But then we
How
have
you
to
know that?
ratify on the side
How do we know that?
because it's in the, it'll be in the way.
Yeah, it's not.
Oh,
If
just kidding.
we-
It's not the
Ms.
same.
Jones, go ahead, Ms. Jones.
It's just the same thing, so you don't get
Ms. Jones,
it.
go ahead.
okay. All right, so here we go. If you cannot remember the relationship, then just follow the rules. So 60 is now my perspective. So if I go to 60, and the rule is adjacent over hypotenuse, what's adjacent to 60? 5. And what's its hypotenuse?
10.
What's 5 divided by 10? 1 half. Your perspective changes, which means that technically all you're doing is the sine of one angle in that right triangle is the cosine of the other angle in that right triangle because they're changing directions. If you cannot remember that, just remember adjacent over hypotenuse. And what's my adjacent? 5 over 10, which reduces to? If you're not going to be able to remember that pattern or that relationship, just follow Sakatoa. Simple as that. Okay? So the cosine of 30 is the sine of 60, which is square root of 3 over 2 because it's my adjacent, lo siento. It's my opposite over my hypotenuse. Tan of 60, what's the relationship?
It's reciprocal.
It's a reciprocal. If I cannot remember reciprocal, follow the pattern.
Square root of 3.
Opposite over adjacent.
Square root of 3 over 1.
So is it just square root of 3?
Oh.
So if I follow the rules, if I can't remember that these are reciprocals of one another, I just follow Sakatoa. What is opposite of 60?
60. So it'll be 30.
5 square root of. What is the opposite side? Not opposite angle of 60. What is the opposite side of 60?
5 square root of 3.
What side is adjacent to 60? And when I simplify, I'm just left with.
Square root of 3.
So if you cannot remember the reciprocal rule, Sakatoa will never fail you. As long as you remember it, opposite over hypotenuse is sine. Adjacent over hypotenuse is cosine. Opposite over adjacent is tangent. As long as you remember those rules, you can't go wrong. Okay? So, from this point on, for every sine of 60, it equals the square root of 3 divided by 2. For every cosine of 60, it equals 1/2. For every tangent of 60, it equals square root of 3. No matter what the outside dimensions are, it's always going to be the same. Because what's the relationship between all 30, 60, 90s? They are what? What's the S word? Similar. They're all similar. They have the same insides. Which means that when you reduce it all down, they're going to have started at the same point. At the same values. So the sine of every 30 is always, the cosine of every 30-degree angle is, and the tangent of every 30 is square root of 3 over 3. If the problem is asking for exact value, these are the values you get. If the problem is asking for rounded values, then you can plug it into the calculator. I can simply plug in sine of 30. And what do I get? 1/2. I can plug in cosine of 30. And I'm going to get,
0.866.
to check if I'm right, I can plug in control divide 3 divided by 2. What is the decimal value of that? Okay? So do you see what we just saw? We just saw for the exact values. If it asks for an approximate value, you can simply just plug it into the calculator. Okay? But if it's asking for an exact value, that means there are no decimals in my answer. Then I need to know that I can draw a triangle and find that. Okay? And when I say draw a triangle, remember that 30, 60, 90, it can just become square root of 3. Where is it? 1 and 2. Because they all have the same factor, right? They're all divisible by what? 5. What's 5 divided by 5? 1. What's 5 divided by 5? What's 10 divided by 5? 2. So if I reduce these, I'm going to already have skipped the reducing step over here, right? I'm going to already have reduced and solved my problem for me. So I either can reduce ahead of time, or I can reduce in the end. Either way, I'm going to end up with the same answer. All right, 45, 45 degrees. The reason why I'm talking about reducing ahead of time is because we're going to reduce ahead of time. What is the common factor for this 45, 45, 9? 6. So that means that each one of these can become a what?
1.
Because 6 divided by 6 is? 6 divided by 6 is? 6 divided by 6 is?
Square root of 2.
Well, 6 square root of 2 divided by 6 is square root of 2. Okay? So I've already reduced, so that means that my final answers will already be reduced. So what is sine again?
A over H.
Oh, opposite over.
So it's gonna be 1.
What's opposite of 45?
1 over.
Am I allowed to have that?
Nope.
No, no.
So if I would ratify it, have you guys caught on to the pattern of ratifying?
Yeah.
What is the pattern?
The answer's gonna be 1 regardless.
Oh,
No,
It's
it's
not
gonna
that.
be square root of 2 over 2.
Cause you're gonna square root of 2 over,
2.
yeah.
so if I asked you to ratify 1 over the square root of 10, what is that?
It's gonna be 10 over 10 over 10.
It'll be.
If I ask you to ratify 1 over the square root of 101, it's going to be,
Square root of 1
Square root of
over
101.
do we get the pattern of ratifying now?
Yeah.
We're good?
Yeah.
Okay. All right. What does cosine mean?
It's gonna be A over
A over H.
Well, because my angles are the same,
So
It'll be the same.
it's just going to be the same thing, right? 1 over the square root of 2. Because my sides are the same, right? It's an isosceles right triangle, so my sides are going to be the same. So what does this become?
square root of 2 over 2.
Wouldn't the other one be just 1?
And the last one is what?
1 over 1.
1 over 1. Because it's opposite over adjacent, and they both are 1 over, which equals. So for any 45, 45, 90 triangle, this is the sine, this is the cosine, this is the tangent. Easy enough? Okay, so I can either reduce in the beginning or reduce in my final answers. Capiche? Either way, I'm going to end up with the same answer. All right, let's see how well you got this. Sine of 39. So where am I starting my perspective from?
39.
39. So coming from 39, how would I find the sine of it?
Oh, B over B.
Opposite over the...
Opposite over H.
Okay, and what's opposite of 39 degrees?
B.
It's gonna be B over 8.
B over C.
B over C. Because my
Oh, yeah,
hypotenuse
it's across from the 90.
is my longest side, and it's across from my 90-degree angle.
So if it gives
My
us,
power, bro.
what if it gives us a 90 degree? It'll never do that.
No. If it asks you for 90, you're going to realize that it's 0 and 1.
Okay.
You can try it. If I do sine of 90,
Yeah, then it would be,
what's opposite?
yeah, it would be C over C.
Yeah. See the problem?
Yeah, C.
It's just going to be, oh, it's my opposite. Oh, it's... Yeah. So it's just gonna, the sine of 90 is uno. The cosine of 90 is zero. If you don't believe me, type in the calculator. It's going to tell you the same thing. Don't worry. When we make our unit circles, you're going to learn it. Don't get too excited. All right, cosine of 39. How do I find cosine? Adjacent side over hypotenuse side. So what is my adjacent side from 39?
8. It will be 8 over C.
8 over C.
It'll be 8 over
Just kidding again.
Okay, tangent of 39 degrees.
over 8.
Opposite side over.
B over 8. It will be
Opposite over adjacent.
So my B over
B over
8.
8. All right, what do you notice about this? I do not know what. What sides do I not know?
B and C. Your hypotenuse and your opposite.
I don't know my hypotenuse and my opposite. So I don't know B and C. I wonder, is there a way to solve for this mathematically?
Yes.
Oh my gosh, there is. So we're going to look at that to see. So first we're going to solve for B. If I was to solve for B, look at the problem at hand. I am dividing by 8. But to get B by itself, I would have to do what?
Divide.
Multiply. We do PEMDAS backwards. The opposite of dividing is multiply. So if I wanted to get B by itself, 8 times the tan of 39 degrees. And if I put that in the calculator, it's going to give me an approximate value of my B. So go ahead and put it in the calculator.
Hey, let me do it.
Hey,
I haven't hit enter.
I got
I'm waiting. I'm waiting.
6.4.
Huh?
Can I hit enter?
Yes.
Other parentheses.
Alright.
It's alright. It'll come up on its own. Alright, so my approximate side length is 6.5.
Yeah.
Yep.
I put 8 in. Sure.
Yeah, let's put
6.5.
So my approximate side length for B is
6.5.
6.5.
Now can't you just do a squared plus b squared?
Okay? Now I could just do what?
A squared plus b
A squared plus B squared to find my
C squared.
C. I could do that.
Awesome.
Or I could divide. Either way.
No.
I'm going to do it my way. You do it your way.
I don't know what the heck is going on.
Would you put an 8 first? Okay, I see. 8 divided. 39. Close that parentheses. I got N points 3.
Okay? So you either could use Pythagorean theorem right here. Good old Pythag there. I don't know how else to abbreviate his name, Pythag. You either could do that or just use your mathematical operation.
I'm gonna do that one because that bottom one is hard.
If my variable's in the denominator, to get my variable out of the denominator, I have to divide what's on this side by what's on this side. So when my variable's in the denominator, it leads to division. When my variable's in the numerator, it led to multiplication. So variable in the denominator, you're going to divide. Variable in the numerator, you're going to multiply. Now, if you're not comfortable with that, who still is hanging around for you to have fun with? Good old Pythagoras. He's always there, and you're going to get the same answer either way you go. So let's just do both to prove that you get the same answer. So if I do control divide, 8 divided by the cosine of 39 degrees, I'm going to get, okay? Now let's do our good old friend Pythagoras. I'm going to take what I got here, squared, plus 8 squared, and what do I get?
Oh my gosh.
10.3.
Yeah.
That's pretty much what we got. 10.3 anyway.
You guys approximated your value.
Oh,
Yeah, I got a 2.
we're supposed to approximate.
Is that what you did?
Yes.
Yes.
Yeah.
So,
Okay, so technically, if it asked for the nearest 100, you would be wrong. If it asked for the nearest 10, you would be right. The reason why yours is giving you the nearest 10th is because what did you round your value to?
6.5.
6.5. So if you wanted to be more accurate, you should have rounded to 6.48 or 6.478. You know, the more decimals you include, the greater your answer, well, the closer to the correct answer you'll get. Okay? But these are all pretty much approximately the same thing, right? All right, so are we comfortable solving for missing sides? Perfect. How do we still feel about trig? How do you feel about trig?
It's great.
It's not bad, is it?
Just a lot of shapes.
It's one shape, triangle.
It's just a lot of
It is, to be specific, it's a right triangle. It's only right triangles. Alright, speaking of which, sine, cosine, and tangent ratios only work with right triangles. Have you noticed we haven't used any other type of triangles? No. We've only used right triangles, which means that these only work with right triangles. Okay? Alright.
Chance it could be a square.
And you cut it in half to make it into a right triangle. See what you did there? Made it into a right triangle. Alright, so here we go. So I have an angle and I have two sides. Well, one side's unknown, but this angle, using this angle as my point of perspective, it tells me pretty much everything. What's the relation between 22 and 67 degrees? Adjacent. What's the relationship between 67 and x? Opposite. Okay, if I have adjacent and opposite, what trig identity am I using?
What's the O?
No, it's not the O. What is it? What is it? Starts with the T. Tangent. So we're using tangent. So if I have tangent, this is called an unknown variable. Okay. So what's our unknown variable? It's called theta. I know you probably hear theta a lot, like for Greek sororities, but theta represents mathematically an unknown angle measure. Cool? All right. So it's our unknown angle measurement. What is the rule for theta? What is the ratio? What is that? What is the ratio rule? Opposite over adjacent. So it's my opposite over my adjacent. Now I fill in what I know. So I have tan. Is my angle measure unknown?
No.
What is it?
67 degrees.
67 degrees equals, what's my opposite?
X.
X over 22.
All right, where is my variable? Is my variable in the denominator or in the numerator? It's in the numerator. Numerator means I'm going to multiply. What do I do? X equals what? What times what?
22 times 2 times 10. 67 degrees.
Beautiful. And I put this into the what? Pull it up. Here we go.
I didn't get that in the
Where did you not get it? Which part? Tell me when to stop.
when you did the 10.
Okay. All right. We chose 10 because what do we know about this one? We know it's adjacent and it's opposite. Remember our socket toe on the front page? Which abbreviation involves O and A? Which abbreviation involves O and A?
T.
T. And what does T stand for? Tangent. So that's why we're using the tangent ratio, because it involves our opposite side and our adjacent side. So we set up the ratio. So the tangent of our unknown angle equals opposite over adjacent. So now we start plugging in. Well, we do know our angle. What's our angle? And then what's our opposite? We labeled it. And what was our adjacent? 22. And at the top we said, when we have our variable in the numerator, that means we're going to. When our variable's in the denominator, we're going to. Are we caught on now? We're on the train? All right. Y'all haven't told me my answer yet. I'm still waiting. What is it? What did it tell us to round to? The nearest? 100. 50? 100.
51.83.
There we go. Degrees. Oh, I didn't hit enter. Let's see if we're right. So if I come over here, it said to the nearest 100. So that means I'm going to go to the
52.
So this 2 needs to, the 8 tells the 52 to do what? Go up. So that is how we got the 83. All right? Are we all in agreement that it's 83 and not 82? Perfect. Your calculator is off, like it died.
No, like I put in the same one you just did, and it gave me 36 points.
Did you put the degree symbol? There we go. Look at that, problem solving. All right, let's label what we have. So we have our what? Our hypotenuse. in our what?
Our angle.
We have our angle, so we have theta. And our adjacent. So out of our SOHCAHTOA, which one are we dealing with?
Cosine.
We're dealing with
Cosine.
cosine.
A over 8.
We're dealing with the ka of the problem.
So X over 8.
Okay, so cosine of theta equals A over H. So now we plug in what we know. What's theta?
40.
40. What's A?
X.
And what's our hypotenuse?
8.3.
Where is our unknown variable?
The numerator.
Numerator means we're going to do what?
We're gonna multiply.
Multiply.
We're gonna multiply.
So if we're multiplying, what am I putting in the calculator?
8.3 cosine 40 degrees.
Oh, it's cosine.
Oh.
Right.
C.
Ow, ow.
So approximately, what am I going to get?
I got 6.36.
6 point what?
6.36.
I got,
What's-
yeah, 6.36.
Why did we put
Because
a
it's
degree sign?
6.35.
Okay.
Ran to the
Awesome.
6.36.
Measurement.
You don't want to take that?
She forgot her degree symbol.
I
Oh,
mean, like on the answer, just put a.
did I put a degree symbol?
I don't know.
What did I do?
No, because I got the same answer.
No, I put a degree symbol
Yeah, I didn't see.
6 months.
because I had a temporary mishap, brain fart.
Oh, so there's no.
We're talking about size, not degrees.
I got 6 months.
Thank you, Alexandria.
Thank you.
Did anyone else do it besides me? Oh, okay. Then it was just me. Me, all alone. So 8.3.
You didn't put the degree symbol in. Oh, no.
My calculator is in degree mode, so I don't have to put a degree symbol.
Okay.
But if my calculator wasn't in degree mode, then I would have to. I will show you. It wasn't a concern yet until the next part of the notes. What was our degree? 40?
Yeah.
And we got
6.36.
I got
6 point. You got what?
6.36.
Okay. If it says to the nearest hundredth,
So the 8 round up to the 5, right?
the 8 will cause the 5 round up, which makes it a 6.
Okay.
There we go. All right. I can't. I just had a burp. 6.36.
So now, could we do c squared minus?
Yes, if it asks for any further information, then we would go back to our good old friend Pythag. You know, we gave him a nickname. So we go back to Pythagoras and do that. Or we could do what instead? We could also do the division.
Oh, yes.
All right, last one. What do I have?
You have the
I have my hypotenuse,
opposite.
my theta, and my,
Opposite.
what is that?
It's a call.
It's sine.
Saw.
It's my saw.
Or is it soft? Or soft?
I will have posted the video finishing this problem on YouTube. Hopefully by the
Wait,
day.
hold on. What are you going to be dividing it?
Divide. Instead of multiply the number, you divide it by the trig identity.
Okay. So it would be 7.1 divided by sine.
There you go. You are absolutely correct. Bye, have a good day. I'm finishing the problem, it'll be posted.
Hey, Johnson.
Good? Alright, I'm stopping it.